Alright, if you find this unfamiliar, this is the equation that we have derived from l8v10 2 3 4 5 all the way. Alright, this equation is your F equals to Ku weak form. Alright, I just want to show you. So this piece over here, including the integration part, this whole thing is our K matrix. This is our U and this is our F. Force equals to Ku. Alright, and it's being discussed in the first 5 videos of this lesson 8. Alright, and then later on we actually went to telling you that the displacement interpolation and geometry shape function and Jacobian, trying to prove to you certain stuff so that you better understand, and therefore we can finally derive K in our case as EA over L. Okay, in other cases we will have different stiffness matrix, but in this our case we'll use what we have learned to actually derive EA over L. Alright, so we're gonna plug out this this K and bring this over here. So our purpose mainly in this video is to prove to you that this K this K is EA over L. So if you still remember, this B matrix is in terms of equals to B1 and B2. Okay, or you can just say BI. Alright, so your BI over here is simply your strain displacement matrix, or the changes of your geometry shape functions across a certain dx, telling you that you have changed the shapes or whatever. Anyway, so this B is equals to this thing, and I could actually expand this introducing the Jacobian. If you still remember the Jacobian now, the inverse Jacobian, I would say. Alright, dx. Okay, so this inverse Jacobian, alright, is 1 over j, right? Because if you remember previously, our Jacobian is equals to dx over dc, correct? Yeah, we have proved to you over here, correct? This is our stuff. So you're gonna take this thing, alright. Maybe if you find it not nice, I'll just crop it all over here. Alright, I don't know where am I gonna put, but yeah, never mind. Anyway, so j is equals to dx over dc, so therefore dc is equals to dx over dx is equals to 1 over j. So I'm just simply flipping it around. Alright, so I'm just doing a chain rule, because if I were to cancel away my I should have write this like this. Okay, so it's dc over dx times dn over dc. So I have dc cancel, I have dn over dx is equals to your b. Same thing. Okay, so I'm just simply changing this to 1 over j, your Jacobian. Okay, so I'm gonna multiply it. So therefore I can simply rewrite this thing. You can say that this thing into 1 over j d dc matrix ni, because this is some shape functions n1 and n2. Okay, but anyway, I'll just leave it right here, and this thing over here is simply over here where skips. We have already gone through all the steps, so the above steps we already gone through, proved to you already. Alright, so this b is equals to 1 over j, same thing, d over dc, same thing, n matrix, n1 and n2. Okay, so I hope that this is pretty clear for you. And then I'll just simply sub in my j as 1 over 2 1 minus c. Alright, oh no, my n over here I'll just sub in as half 1 minus c and half 1 plus c, because this is the shape functions for the c domain. If you remember, we have plot from the u to the x and to the x to the c, so we're going to use the shape function of the c to actually sub it in. Okay, that's something that I found out now. Alright, and then you're going to differentiate d over dc now also. Actually, if you differentiate d over dc, what do you have over for here? If you differentiate half minus half c, if you differentiate in terms of c, you'll have half only. Alright, so therefore you can see that this is minus half over here, because this is half times 1 minus c, so its other words is half minus half c. And then if you differentiate no c, you cancel this and you cancel the c, you have minus half over here. Same thing, if you differentiate this thing, you'll get this half over here also. Okay, it's It's something that you need to really understand the steps. And therefore, don't be confused by all this big chunk. This big chunk is just telling you that your b is equals to 1 over j, alright, minus half. That's all. Okay? Or your b is equals to dn over dx. Okay? But anyway, I'll just show you this already, your strain displacement matrix. And then I'm going to use this b and I'm going to sub back into our k. This is our k function. Okay? So my b over here, we know that it's equals to half 1 over j multiplied by this thing. So just simply sub in as this thing over here. This is b. Alright, and you have a b transpose over here. So b transpose is simply transposing your this thing towards this thing. So just simply rewrite as minus half and half over here. Same thing lah, okay? So this thing, if b transpose is equals to like this. Alright, so I think you get what I mean already lah, okay? So this chunk over here is actually your b transpose. So I didn't cheat your feeling. Your e is still over here, your e is still over here. It's just subbing in the b and the b transpose only. The integration I didn't actually remove also, just double check. So therefore I'm just simply rewriting stuff. And then now we have to unwrap the present of the v, because v is equals to area times the length. Alright, which is the dv over here. Alright, so and therefore dv is equals to area times a small change of a dx. And therefore this dv, you're going to change into dx. And then the a, you just bring it up over here. That may be a little out of nowhere, so I think I'll just bring this out a little bit. Alright, so as you can see, there is 1 over j and 1 over j over here. Alright, once just now we have shown you, so I'll just bring this 1 over j out from the integral. Alright, from this integral over here, and the e, I also bring it out over here. Okay, and then we know that just now we say that the v is equals to al, area times length, so I'll just simply change this dv as dx. Okay, and then this thing integration I'll change to l. I'll just bring this a out also. Okay, so if I were to merge them all together now and put them nicely, alright, and then this ea I'll just bring over here. We know that 1 over j times 1 over j is 1 over j square, so I'll just simply rewrite this as 1 over j square. Okay, so hold on a while. So if I were to write this down over here, as you can see, this, your k is equals to ea over j square, this thing over here, your integration in terms of l, and then your b and your transpose b transpose, alright, the same thing, and then dx. Okay, so we have shown you that how we prove this form already. Alright, then you were to use the dyadic tensor, you just multiply the matrix, eventually you expand out to this form. Okay, quite straightforward, right? And then after which we take this form, alright, we take this form, and then I factorize out the 4 because it's 1 quarter, right? So I just factorize out down into the denominator. So what I have is 1 minus 1 minus 1 1. Okay, we are somewhere there already. Alright, and then this integral we also we still leave it here. Alright, you may wonder where does the integral comes from, because the integral is over here. The dyadic tensor, if you multiply, is over here. So when you do dyadic tensors, you don't integrate. So in other words, you just bring this integration over here at this back side, and then this thing over here. Alright, this thing over here is simply your this thing. That's all. Okay, well your ea j square is this thing. So instead you may misunderstand what I mean. So therefore I have this thing over here. Okay, so this thing I just simply bring it over here, and then I rearrange for you, factorize out the stuff. But I just want to explain to you that this integration comes from where only. Okay, so I'll just simply paste it now over here. Okay, let's continue. Okay, next we know that j, the Jacobian, is equals to dx over dc, right? Because now we are dealing with j, we have some form of ea over l, but we haven't proved to you that how do we get the l. Alright, so we just simply rearrange. We bring this dc upwards, so you have dx is equals to j dc. Alright, so therefore you sub in our dx, which is this dx over here. this dx, you just sub in as j dc. So therefore, as you can see, is over here. All the rest over here, EA 4j square, I didn't change anything. As you can see, it's the same. I didn't change a filling. So I'm just simply switching dx in terms of j dc. That's all. Okay. So now I have this form first. Alright, this form over here first. Then now when I see this, I see that there is a j over here, right? So this j can cancel out with this j over here. So therefore I have EA 4j, alright, integrating from dc, integrate with the length lambda. The lambda, if you remember, comes from here, the lambda. Alright, this is come from the c, and we know that L is equals to L, but c is equals to 2 for some reason, for the Jacobian in the Jacobian video. But anyway, let's don't sub in as 2. Let's just continue first and see how. Alright, I'll just copy this thing, I'll just paste it all over here. Okay, so as you can see, it's the same thing. I'll just paste it all over here. Alright, and then let's continue. We know that j is equals to length over 2. Alright, so if that's the case, then 2j is equals to your length. Is it? Ding ding. Yeah, correct. So 2j is equals to your length. So we have 4j over here. So 4j equals to 2l, right? And therefore we have also sub in 4j as 2l, while the rest are the same. Alright, and therefore now we're gonna have this one ready, which is still your K matrix. Alright, you're gonna evaluate this thing over here. So we're gonna solve this integration, and we have, alright, from +1 to -1, because as you can see, the graph is from +1 to -1, which is the lambda over here, which is 2 lah. So this is why I say 2 just now, right? So at least you get to see the meaning of that. Right, so once you integrate this thing, if you integrate, you have c, right, from 1 to -1. So c, so you have, so for the definite integral, if you sub in 1 as c, then you have 1 minus -1 is equals to 2. Alright, so therefore this is being represented over here. Alright, so if that's the case, we can simply rewrite this thing as 2. Alright, so 2 cancel with 2. Ta-da! You have k equals to EL over L. Yay! Finally! Yeah, you get what I mean. It's really finally that thing. Alright, I can't. Yeah, I don't know what is this other shapes. Then I'm gonna kill myself already. But anyway, this is finally will show you that the k is equals to E over L. Alright, and yeah, this is the proof. And I shall see you soon.